Good afternoon, ladies and gentlemen. We will be resuming the conference, and this time it will be a panel discussion on discussing strategies and workable approaches. I invite our moderator, Srimati Rama Devi Lanka. She is the Director of Emerging Technologies, Information Technology, Electronics and Communications Department, Government of Telangana. I request her to come up on the dais. Our first panelist is Mr. Nitin Kumar, General Manager, Industrial AI and Data Science from Reliance Jio Platform Limited. Request you to come up on the stage. Our second panelist is Dr. Akansha Kumar, Principal Data Scientist from Reliance Jio Platforms Limited. Request your presence on stage, please. Our next panelist is Mr. Phani Karnati. He is the head of AI and ML, Vihavi.ai. Request you to come up on stage. Our final panelist is Mr. George Abraham Prem Kumar. He is the robotic AI and IA researcher from Logos Informatic. Request your presence on stage. Over to you, Srimati Rama Devi Lanka.
A very good afternoon to everyone, to a few of one I should say. Well, this discussion that HIMTech is organizing today is at the right time. We have just celebrated our 76th independence, 75 years of independence, and in the next 25 years, India at 100, I believe is going to be a technological powerhouse. India is going to embrace Industry 4.0 technologies, and it's just not the government alone, but it's going to happen in every sector. While for the government, we are looking at 5 key areas, agriculture, healthcare, education, mobility, smart cities, and environment. And as a proactive government, we have already come out with our own framework, AI framework. We have set up a team called Telanagana AI Mission, which is working on the framework. And we have identified use cases that can deliver social good in areas like agriculture, where we're using AI for quality assaying, for, conserving our species, our endangered species like tigers. We are using AI to actually monitor and protect them. And a recent one that we have used AI is in e-voting project. All of us know during COVID, most of us, when elections were happening, we really did not want to go and vote, right? So we have developed an app, smart phone-based app to actually, for voting, where we have used AI and blockchain, 2 technologies. So while the government is doing so much, I'm sure the industry, in different sectors are also using AI. Like it could be the pharma sector, defense, or information technology, of course, is using it on a large scale, e-commerce and so on. While the government is using it, but it's very critical for the manufacturing sector, why the need to adopt AI. While various reports actually indicate, different numbers in terms of the market opportunity. For example, a report by, I'm not sure who, but in 2022, it's a $2.3 billion worth of opportunity in AI. This is what the report is stating, which is likely to increase to about 16.3 billion by 2027. Well, the market opportunity is there, but what is the manufacturing industry need to do, Why is that we are discussing so much about AI? And why should the manufacturing industry should look into AI? Well, I would say there are 3 top reasons. I think some of them have already been covered by Dr. Sailesh. Well, the first one is, personalization. Customer is actually expecting personalized solutions, specific solutions, That's number 1. Second, manufacturing process is becoming very complex and need to be adaptive. And the third one that we are looking at is need for performance and, productivity. These are the 3 top reasons that I believe why, the manufacturing industry should look at AI. while AI applications, we find use cases across the value chain, starting from your product design, conceptualization and product design, then moving on to development, then operations, maintenance, and safety. So there are innumerable AI use cases across the value chain of the crop that can deliver, increased productivity, efficiency in operations, increased safety, predictive analytics, and so on. There are so many use cases. Even morning, Dr. Shailesh ji was also speaking about. So now let me actually turn towards my panel. We have an expert of panelists here. Let us ask them to demystify this AI, how it's going to actually help the manufacturing industry. What are the challenges that the industry is facing today? What are the strategies they need to adopt to leverage AI? And what are the various use cases that different industries can adopt? So, and we have divided this session into 3 areas, starting with initially on the process and control optimization. So that's an area where we need to look at, how AI can be leveraged. So the panel will actually come out with what are the current systems in place, that are right now. The second one is how can AI augment these processes? And third one, what manufacturers and utilities can do to unlock the potential of AI. So first I'll start with Nitin, who has extensive experience in that area. Over to you, Nitin.
Hello. Hi. So my name is Nitin Kumar, and little bit of a background on my my stand on how do I know about these things. I come from an operational background. Basically, I come from a industry which has been working for last 50 years, and it has seen and driven the automation industry towards next level. I'm come from oil and gas background. So oil and gas, when we say that it is based of 3 industry sections, where we call as upstream, midstream, and downstream. And upstream is the industry section where you search for oil, dig for oil, and bring the oil to the ground. Midstream is the section where you get that oil to a refinery or a end market area. So it could be on the local in country, or it can be international borders. So you can generate oil in a Arabian continent and send it to Japan or send it to Canada. That itself is an industry in itself, right? And what we call that as a midstream industry. And then the third section of the same industry is basically downstream industry, where you process that oil into thousands of components and thousands of products which we use in our everyday life. So you can imagine the sole of your shoe to the oil in your hair all has components of crude oil. Even your cloth has some nylon in it that is coming from crude oil. So my experience expand from all this industry in different levels, and I have seen the propagation of automation in industry from a very crude steps where we do things manually to now being done by robotics or drone based on AI system as a background, right? This all industry is basically is a gold mine for data. There is huge amount of data, but the only thing is that sometimes the data gets lost, the information gets lost, and you cannot relate what this data can do in terms of your next decision making, right? So if we talk about process optimization and control, that is the area where the connected systems are working together for some objective. That objective can be motivated towards safety or profitability or maintainability, whatever is your end objective, that system will work towards. So if you talk about a simple turbine or a compressor or anything, they are basically trying to do one particular job in a whole connected system. When there is a connected system, there is a huge amount of correlation between many variables. These variables are having different ranges to go through. They can operate on a lower end, they can operate on a higher end. Same like your car. It can operate in one gear and make you reach to a destination, but that is not the most optimized way. So what is the most optimized combination of this particular set of variables in an industry so that the highest amount of profitability can be made? So that is what we are trying to achieve in an optimization. We are trying to achieve an objective which will help us create more value from that particular installed system. So once we have, so the legacy systems are already there, meaning you have many types of application computers, equation solvers, which will provide you that objective or optimized control. But mostly, whenever we simulate something, we try to reduce the order of the system. Like, there is no simulation in the world which can replicate a physical system to the last molecule. There is no way. We always have to take a lot of assumptions. We have to take a lot of a lumping of equations, right? So we will always lose some degree of order in a system when we simulate. So to understand most of the optimization currently in place in the industry is more of a wide scope optimization rather than a deep scope optimization. So wide scope meaning it will understand the boundaries of the system and try to optimize in those boundaries. But it will never tell you what is the component of the system making that constraint available. Like for a car to be running on a peak performance, it might tell you that these variables are the best to optimize. The gear ratio, the power ratio, the fuel economy, the carburetor, everything else. But it will not tell you whether it will be the last carburetor valve which needs to open a little bit more so that it can give you higher performance. So the deep optimization is not yet there in any of the optimization system. The AI, when we do it in a proper way from the ground up level, we may be able to challenge the deep optimization layer, where we'll unlock the constraint to a higher optimization layer. Meaning, previously you are running your car at 100 kilometers per hour, which is giving you some on loan conditions, some kind of fuel economy. But if you change some parameters, some design parameters, some tweaking, that particular constraint can go up, and now you can operate at 120 with the same fuel economy. That is the deep optimization which is possible by doing AI system, because AI provides you a high amount of flexibility in control and optimization and simulation. So I think there is a scope not only to challenge the wide optimization, but to go to deep optimization on an industry level and bring much more value out of the system than the install base which try to restrict it. So that's my take, I guess.
Thank you, Nitin. In fact, that's a very good point that you brought about how AI can actually help in carrying out deep optimization that will eventually help in increasing the profits. So next I move on to George, let us know, what are the various use cases that you can share with the audience, like in different industries it could be.
Hello. Thank you, Rama Devi madam. The process optimization is adding a more value for our company. I can give you some examples. Like, so if you are a production company and if you are segregating your products as quality number 1, quality number 2, and quality number 3. So you when you are giving a manual inputs and you can't able to achieve more the quality number 1 product. So when quality number 1 product which is going to give you more profit for you, quality number 2 is going to be lesser price, and quality number 3 is going to be more lesser price. So you want to make your machine to produce only quality number 1. So what we are going to do is, here we have to undergo the process optimization. So we input the AI and we use the proper data of how the machine is. We have to understand the machine and we have to simulate it for how it's producing the first quality of product. So the same simulation we are going to take here and we are going to implement in the AI to automate the machine to produce only the first quality of product. So automatically the profit will be get increased for the production company. So that's the main important value for a production company to use AI as in the process optimization. So whereas it's come for the control, you have to control it through the data. So the data which you are going to give, the data is the main important set here. So it's like when a machine is not working properly and when it goes for a maintenance, so you have to take the data from the lake of data outside. So this come under the control optimization. So these two processes are going to give more additional value for the production companies. But in come for investing, it will be in a little higher end. But when you're calculating with your hiring employees, training them, and making them to adapt for all the things, it will be just adding more profit for in your things. So this is one kind of example which I can able to share and pass.
Yeah, thank you, George. Essentially, you're saying that AI can be used to improve quality of the product, which in turn will lead to more profits, and you can even use it for hiring good talent.
Yeah.
So now I'll turn towards Akansh. What are your views on this?
Point out a couple of things, right? First is in processes, we use a lot of dashboards, right? And I think Dr. Sailesh had pointed out dashboards are graveyards of data. So possibly an optimization, we would not actually need a person to look at the dashboards and tell us what action needs to be taken. Right? So optimizing a process and controlling all the parameters is one of the, I would say, a gap in the current processes. I think that is one of the areas that needs a detailed focus and possibly development of platforms and framework in that. The second thing is the unsupervised ways of finding causal factors. Right? If you look at manufacturing plants, they have a lot of valves, they have a lot of compressors, they have a lot of heavy equipments, and understanding the behavior is humanly impossible if I just look at the pattern on a dashboard. Right? So using AI to know anomalies in it, right, in a real-time manner and then give the right alerts is another aspect that I would say. And the third thing is a digital twin, right? And a digital twin, as also pointed out by George, digital twin is really essential for training purposes, right? And for simulation and optimization, obviously it helps, but from training perspective, digital twins are a need of the art at this point. I would say these are the three aspects the manufacturing organizations or the digital services of manufacturing organizations need to focus on at this point from a process and control perspective.
Thank you, Akansh. That was very crisp and clear, the three things that you have described, especially the last one that you said, digital twins, is an essential requirement when you're actually using AI, which was, again, reinforced by Dr. Shailesh ji also when he presented the digital twin. Now you are the last one. So please share your views on this.
Yeah, I heard everybody, and it's all great insights. One thing that I would like to focus upon is your predictive maintenance when it comes to the optimization of the things, right? Often we call it as a equipment failure prediction, right? It is essential for every industry. Most of the industries download that part and they think that they are doing regular maintenance. Okay, so like let me put this way, like probably you have you are on a trip and your car broke down. So how upset you would be, right? And at the same time, if you have a big order and you're on your toes fulfilling that order, probably for a Christmas or a Thanksgiving, and suddenly your assembly line broke. So it has a huge impact on your deliverables, and no customer will wait for you, right? So the thing is, most of the people think that they are on the regular maintenance, but why we need the AI in that case, right? So what happens is there are various instances where you did the maintenance, and before you go for the next maintenance, the things fail. Right. So that is detrimental for every company. And with Industry 4.0, it was not a very doable task before Industry 4.0. But with Industry 4.0, like many systems talking to other systems, vehicle-to-vehicle interaction, vehicle-to-human interaction, a lot of sensor data is being able to be collected with IoT and nowadays with 5G. Right, so the data transmission has become an easy task, and with computation and storage being cheaper and computation become faster, your data can be processed and the insights can be given real time, right? So just if you turn off your car headlight and leave it there, if you can get an instant alert by the time you go to your apartment saying that, hey, your battery is draining down, fast. So it alerts you, right? Rather than waiting for next day when you're in rush and coming to see that your battery is dead. That's a small example, but when it comes to the industry, it can be a bigger applications, right? With this data from the different equipments, if you can tame that data and make use of that data in the right way, which gives better insights, you can precisely predict when your next equipment will be failing, right? And you can alert your maintenance team to get that repaired, okay? And the other side of it, and most of you are from Hyderabad, you might be seeing some Saturdays, most of your power will be down for in the first half of the day, saying that the regular maintenance, right? You have to turn on your inverters. Why is it happening? Because you have to have a regular maintenance. Is it really needed? We don't know. But just as a preventive measure, they are maintaining it. So it is a cost, right? Maintenance is a cost. So if you talk about the huge industries, many equipments don't need the maintenance. You maintain unnecessary. You go and invest on maintenance unnecessary. If you can predict whether that equipment really need that maintenance or not, you don't need to spend your amount on that one. So that is one way you can save a lot of money, okay, on the things, right? So you can predict your remaining useful life of the equipment when you want to replace the equipment, right? So if you can predict the remaining useful life, say same thing with the battery, your remaining useful capacity, you know when you have to replace your capacity, and it has wider applications, okay? And when it comes to the maintenance, it's not just the industry which is on 10,000 square foot, but imagine the windmills, wind turbines which are on the top of the hills. You don't need to send a person over there when the maintenance is not needed. And probably in the sea or in the, in the tunnels or in the mines, you don't need to send the people unnecessary, right? So you may have to do your AI-based analysis and figure out whether the maintenance is needed or not. So this is one important application, and definitely along with the data scientist, you need a domain expert who can really try to cater that whole as an ecosystem, as Dr. Shailendra was saying, that you need to understand the whole ecosystem and try to mitigate the loss, both in terms of detrimental failures and in terms of unnecessary maintenance, okay? So this is one way of the whole optimization ecosystem, a small part of it, right? That plays a vital role in saving your revenue. Yeah, so that is mine.
Thank you, Phani. Like you kick-started the discussion on predictive maintenance, in fact, that's good. I liked what you said. One is you really don't need to have maintenance contracts once you have those, solutions that can actually send an alert saying that predictive maintenance, if that is going to actually work, you can do away with the contracts, Yeah, that's a very good point that you said. And the other one that I liked was you don't need to send people to check the power windmills and all. In fact, in Telangana, we have used similar solutions to predict the failure or defects in the transmission lines. These transmission lines are located way above, and really it's such a difficult task for the staff to go there, visit, and, to identify the defects in that. So we use actually drones to capture the data and an AI algorithm that actually predicts, which nut, which bolt is going to give away. So such kind of useful applications really help in it. Now I actually turn to Akansha, so what are you, especially when it comes to predictive maintenance, a McKinsey report states that it could generate about 0.5 trillion to 0.7 trillion across the world. That's the potential value that we are looking at. And moreover, the combination of IoT and AI are actually providing very exciting solutions for predictive maintenance. So please let us know your views on this.
Yeah, thanks, Rama Devi. Yeah. So I'll possibly, I think the failure prediction has already been spoken about. I would rather talk about the health quantification of equipments. I'll give a I would give you an example. Let's say a transformer. A transformer has a life of almost 70 years, right? A manufactured life. And due to the operational variability and the maintenance variability, the life automatically decreases to 50 years. right? Along with predicting the failure, if I mean, AI can help you identify the points, like the pain points on how to improve the life of a transformer. And that's like improving the life of a transformer by 10% directly adds to your bottom line numbers by 10%, right? So one of the important aspect of AI is to, I would say, unravel the opportunities in terms of finding the right control parameters and finding the right maintenance schedule to increase the life of any heavy equipment, right? That's one thing, right? The second thing is knowing, getting an estimate of the failure can help us in optimizing our service personnel, and that also adds to our bottom line. Right, so I think these are the two aspects. Those are essential in the predictive maintenance space across any heavy equipment. May it be a transformer, or it's a compressor, or it's a windmill, right? Or it's an escalator or an elevator. Doesn't matter, right? So these are the two things I would like to highlight where there is still opportunities for AI to kind of help in the process.
Actually, that's right what you said. If you can get a handle on the control parameters, you can really increase the life of any equipment, or not just transform any other equipment, where you can tweak those parameters or get alerts ahead, before it actually collapses. Yeah, Nitin, you're the last. I think you are also there, right? Yeah, Nitin, next over to you. Yeah.
Right. So I think everyone repeated what maintenance, reliability, and upkeep of an equipment can do. I think I learned about the maintainability and reliability of the equipment 5 years ago when there was a live use case for Rolls-Royce and GE. They have the jet engines installed on all of their Airbus and everywhere. So GE and Rolls-Royce provide those Pratt Whitney and Trent engines. The purpose of a plane is to always keep flying. That's how they make money. But if any maintenance happen or anything, they have to put it in ground, and then that take time to turn around the plane to make money again. This was a big down selling kind of an idea where the airline always despise any engine which will have a high chance of failure, high chance of downtime. So these two companies started collecting data. The data was like 30,000 data points from an engine, jet engine, and then they started analyzing it and finding the root cause for each part. They didn't stop from the predicting part. They didn't really stop from where the predictability happens. They said, okay, my engine will fail, that's okay. But they went back and find out which part is causing that failure. They started optimizing the part side of it. That is something of a power which basically came after 5-6 years of continuous study and root cause analysis and all kinds of generative AI, generative design engineering, and bringing up multiple aspects of engineering together to understand the root cause and bring up to the space where now they can say that 95 to 99% of the time the jet engines will not fail, or at least will not have any kind of a downtime. So that's how they started selling their flights. Now you will see that Indigo and the companies now they are ready to say that if there is a downtime in my flight, I'll pay you back your fees or whatever the charges they will incur, and that business is now able to adapt. So what I try to summarize from all of these discussion is basically AI is just an enabler of function or a business. We might have to bring up to the speed of the whole business to adapt what AI is giving them to do, or the leverage part of it, right? So that's my take on maintenance and reliability part. It's not only one predictability, it's kind of a going beyond what predictability can achieve for your business to make it much more viable in the market, right? I think that's my
Yeah, thank you, Nitin. That's the power of AI, identifying which part is really contributing to the overall, defect or change in the performance, or, a reduction in the performance. Well, I'll move on to George now. Yeah, George, please share your views on, what can be done, how AI can be actually used in this predictive maintenance, and how it can actually contribute to the overall value to the organization?
Sure. So this predictive maintenance is basically it's like maintaining a machine. Actually, it's like that. A machine is having a life of a date. If you like, for example, a machine will go for 10 years. So after that, it needs a service. So otherwise, it will go into crash, right? So that service place and the crash place. Before that, we are going to stop the crash of the machine. So there, the productivity is company here. So when comes to companies, when comes to small devices, so we will not feel the loss of it. For example, in our home, we may have a smart environment and we may have our mixie damage or a grinder damage. 1 or 2 days we can manage for doing these things. But when it comes to oil industry or when it comes to a bigger industry, the 2 days of the machine is not working, that will put the entire company into a great loss actually. So in that place, we as AI experts, we are suggesting the companies to go for this AI to implement in this certain place. As well as, and then when the people are using cloud, it will be very useful for other companies also to understand the same kind of devices which they are using. So it's more or less this predictive maintenance in AI is going to teach all the other companies also which using the same machine as when it will be failure and when can you able to change these, and all these details will be applied in the data market. So when the pool of data is available outside, so we can reduce the problems come for the machines. So they can improve the same kind of profit and they can improve the quality of the machine still more.
Yeah, thank you. The key is the data, having data to understand or to come out with predictive maintenance, that's
the data for others also. The data which this machine is capturing, this predictive AI is capturing. AI is entirely related to our cloud. So when we are using the infrastructure of cloud, so the others will also come to know that this machine will do like this only when we are using it. So in this place we have to do. So that will be automated again for other, not in the human brain, other AI machines. So automatically it's like
can be reused is what you are trying to say.
So then these digital twins are coming. The same kind of machines can be copied to the other location also. This operation will certainly happen in that place because of the digital twins. Thank you.
Right. With this, we'll move on to the third, focus area, which is again supply chain. So supply chain is a very interesting area now, and especially in the pandemic, all of us have seen, all the supply chains are broken. Even now, the companies are trying to get back on their feet. Especially the chip industry is still, trying to make up those losses. So we would like to understand, how AI can actually enhance either, forecasting better, or can it improve inventory management better, or increase warehousing efficiency. So what are all the things that AI can do in the overall supply chain? While, again, McKinsey report says that 61% of the executives who actually implemented AI in supply chain, they said there is a decrease in costs to the company. That is one. And it also contributed to the increase in revenues. So that is the potential of AI that we are looking in supply chain. So I'll start with Akansha, in the supply chain. So please share your views on this.
Yeah, I think supply chain is one of the important aspects, because we in manufacturing, right, we have the sourcing of parts, we have, and then once the equipment is built, right, you have to sell it somewhere, right? So there has to be a demand and a supply aspect to it, right? And there are a lot of variabilities around, right? You might have seen the pandemic, how is that affected the chip industry, which affected laptops, which affected cars, which affected connected components, right? And I mean the whole the flow, right, and the whole connected area industry got affected, right? So getting the right price in supply chain, AI plays a very important role in that. Keeping the right inventory, like for example, possibly some smart automotive industry, if they would have kept a good, if they would have predicted the pandemic, and they would have kept a good cheap thing, right, in the stock, they would not have got affected. Right? So the right price, the right inventory, so that the wastage is reduced, you still meet your customer service level, and AI plays a big role in that. Right? A lot of these supply chain problems have been solved mathematically in the past, but lately, due to AI unraveling a lot of other parameters that a human brain was not able to decipher, right? The whole supply chain area has been affected in a positive way. The second thing is the warehouses, right? Warehouses, optimizing the warehouse actually adds to the bottom line directly. So having right models to right AI models to optimize the warehouse slotting or picking of products, right, in large warehouses, reducing the congestion, right, affects the margins, right? So in the supply chain area, logistics, the inventory, the safety stocks, the right price, getting the right, predicting the right demand, right? Predicting the right demand also needs to take a lot of causal factors, right? So if you know that there is a festival and you have to incorporate that in a demand, obviously you do not predict pandemic, but then at least what you can say, if something like pandemic happens, do I have a fail-safe mechanism, right? And so a lot of these questions can get answered through AI, and there is a strong opportunity of AI in supply chain, and I see this across manufacturing, retail, oil and gas, right? Look at crude price, right? I mean, the price due to what? Due to the global effects, the price varied a lot. But then again, right? Again, due to some countries still taking oil, right? The price got normalized, right? So understanding the effect of these specific causal factors and incorporating it into pricing models and demand models is one of the key aspects that still needs that still isn't mature in the AI industry now. I think there's a scope and an opportunity in that.
Thank you so much. In fact, when you were talking about this, which is relevant to the industry, I was actually, correlating it to different use cases within the government. For example, we have a huge public distribution system, right, from Government of India to the different states. And it's food grains, it could be agriculture subsidies, fertilizers, you name it. There's so many things in the supply chain. While we are able to have basic systems in place, but we do not really right now have any advanced, solutions that can really help in optimizing, number one, the process. Second, ensuring that the quality of the grains or whatever that is supposed to reach the last mile, are we maintaining that? That's second. And third important area that, as you mentioned, is price discovery. For example, in agriculture, right now most of the farmers, they do not know what price, their vegetables or their, rice, wheat. Of course, there are certain food grains that have MSP, but other than that, most of the farmers, they do not know at what is the demand basically. So these are the areas, where probably Reliance can help us within the government also. Yeah, thank you. That's a very insightful, discussion that we have had on this. I'll move on to George now to actually add to what, Akansha said. Yeah.
So I can give you a good example in supply chain in food delivery actually. So when it comes to AI, recently the food delivery companies, you may see the list of foods in your app. So you will list of the menus and everything. So whenever a menu is getting over in the hotel, so they just if they are because of they adapted the AI in supply chain, so they just close that point. So automatically in all over the nationally which they are using the app, the menu it will be taken out. So it will be very easy for the consumer to know that that food is not there in the hotel right now. So we can go for the other hotels by searching. Most of the companies, when we are approaching the supply chain, which what they are looking for is like they may problem if you are calling and asking for a stock, they'll immediately ask us to wait in the call for minimum 2 to 5 minutes, and they will check and go for the stocks whether it is available or not, and we have to be patiently waiting in our phone. So when we are using AI in supply chain, we don't want to worry about the understocks, as well as we don't want to worry about the overstocks of our things also. So by this way, it will give more value for the delivery, automatic delivery of the company of shipping also has to be happen. So this is how this will work on. Yeah,
that's a good example that you shared,
thank you.
Food supply. In fact, most of these companies, Swiggy, Zomato,
Yes,
probably
really,
they are already, incorporating that.
Yes.
But most of companies are yet to, still incorporate that.
Yes.
Yeah. Thank you, George. Then, next over to you, Phani.
So let me start with a small example. Like when you construct a house, what items should be ordered well in advance and what items should order later part, right? So you don't order bricks, you order the steel and the cement for the foundation, then you go with the bricks. So that's the house, and we know it traditionally how to construct the house. But when it comes to the big project like a dam construction, or probably you're erecting a company, a steel company right from the scratch, right? So you should know those things. So if few items they may get spoiled if you order them well in advance. And the other side, when it talk about e-commerce companies, right? So it is very sensitive for us to say like they are not serving better. Like where that effect comes from? If they say more, no stock, you will be very disappointed, because your occasions are important for you, right? So for every e-commerce company, it's very essential for them to maintain a safety stock. What does it mean? Is like this level of the stock which they should always possess, so that they don't say no to a customer, anyone. So that's what Akansha was also telling, right? So to consider that small piece, so there is a lot of maths that has to done with respect to artificial intelligence, right? So you have to consider, because not every order which you purchase, they have it there in warehouse. Sometimes they have to ship it from China, and sometimes it will be on the water, right? So they have to consider every factor. And the other thing is your warehouse, right? Every space in the warehouse comes with a cost, right? You don't maintain unnecessary stock on the warehouse if you don't need them, right? So you just predict at the SKU level what are all the items that are sold fast and what are all the items that are lethargic, they are moving slow. Okay, if you have these insights, to get these insights is not that easy. So you have to do a lot of analysis, a lot of clustering things needs to happen over the period, and collect the data from the history, how my items are sold, what is my peak, what is my crust, and give it to the machine learning model. That model tells you what are all your items and what stock you have to maintain, what is your economic order quantity, EOQ we call it, okay? Such that you don't order too many also, right? As George was telling, you can't order too many so that I am on the safety stock, right? So you have to maintain in such a way that you have to balance your profit, you have to balance your stock, right? So these are the challenges when it comes. So you have to analyze a lot of factors, okay? And I'll just end with one small thing. Probably in the urban population, the item is sold differently. When you want to expand your business to the rural population, the same product response will be different, right? Same thing with any of the industries also, right? When the place where you establish how to manage your resources at that point is important. So AI is matured enough at this point, at least in the supply chain management. I mean, still a lot of research is going on, but at least in the supply chain management, it's doing really good in predicting your stocks, the stock of the items very well in advance. Okay, so that gives what is the advantage of AI in these areas?
Well, I'll give you the opportunity to speak at the last for this particular, focus area on supply chain, Nitin.
Right. So I think pretty much all the components of supply chain management has been covered by the expert panel here. I'll go to the first principle of supply chain management. The first principle of supply chain management is made for its certainty, meaning you send something from one point and it should reach to the other point. The supply side and the demand side gets connected by a pipeline. That is certainty of the system being designed for it, right? The main quantity which should concentrate on while deciding the robustness of the supply chain or reliability of the supply chain is what we call in mathematical terms the uncertainty quantification. If you can quantify that uncertainty, whether there is a disruption in the supply chain, whether my inventory is going to go low, whether the demand will outrun the supply, or there will be a disruption in supply. All these uncertainty, when can be quantified by AI, that can bring much more live reliability to supply chain pipeline, which is originally designed to sustain all this disruption, right? That's, I feel like that's the area we should be able to concentrate upon, to challenge the uncertainty and understand and provide the mitigation point where after certain level of uncertainty we should take action, right? That after certain time, like there is a festival coming, then there will run out of all the supply, then we should restock. That is the quantification which we can take from AI, learning from past experiences, learning from new models, and then bring that robustness to supply chain management. And that can apply to any micro level supply chain or macro level supply chain if you go for a national supply chain, international or global, if you say so, right? I believe that's the key focus area we should figure out, that is uncertainty quantification in the supply chain management.
Yeah, that's a good point. How do you remove uncertainty to ensure that a product that is being shipped from point A essentially reaches at point B within the stipulated time, that's a very good point. Now, I think we have covered all the three areas. Just we are wrapping up this session by just one last question, which will be posed to all of you. It's a 30-second answer you need to give it, sum it up in. So the question is, what are the top 3 things the manufacturers or the industry need to do to leverage or adopt AI? I start from Nitin, yeah.
All right. I get so I'm manufacturing background, we challenging 3 things. First is the vision. Want to have AI as your first strategy, right? Then you need to have a fearlessness in yourself, so you can break down the old system and bring out new system. That basically requires a lot of fearlessness, right? And the third is the fast fail approach, meaning when we have a manufacturing system, we are very comfortable with equations. We are comfortable with our mathematics. We don't really appreciate an engineer failing in his calculation. We try to give them hard time. But if you want to do some kind of an experiment in AI, then you need to be very comfortable with fail first. You can fail a lot of times and then maybe you can succeed. The latest example is the SpaceX model of testing.
Right. Yeah, vision, bold, I would say fearlessness is
fearlessness, boldness.
Bold, and fast fail are the three top things that you are looking at. Over to you, George, for the top 3 things. So it's kind of, yeah, please.
Sorry. So according to me, the approach of AI from the company side, if they want to initialize, if they want to start implementing AI with them, they have to come out of their old infrastructure to the current infrastructure to update. So usually the companies will have the fear of costing on all those things. So what we approach, like where we approach to how to implement the AI in their product first. So once the product get implemented and they feel the profit of that products and everything, then they'll change their entire infrastructure to get automated. As they know that there is some kind of value is there, some kind of profit is available in these things. But the investment for do the R&Ds for their infrastructure is nowadays is going to be very expensive nowadays. So what our main approach, our main approach to the company is like, first we will try to implement something in their product in AI, so that they will be, nowadays everybody talk about AI, but people doesn't know what is AI, but they will talk about AI. The problem is like, they have to feel it first. So we will make them to feel, and then we will make them to implement the AI for the entire infrastructure.
Sure. Infrastructure awareness
Yeah,
is what you have.
first we will implement to the products of them.
Okay.
So the AI awareness will come for them. Then we'll go for the industry to change.
Sure, sure. Yeah. Next, Akansh.
Yeah, so the
Top three. Yeah.
top three, right? The first thing is AI is just not a buzzword. AI is a necessity. Simple, right? There's period. AI is required. AI is the future. The second thing is AI cannot go in a silo. It's not like just hire data scientists and just give them data and it will work. No, AI needs a lot of domain understanding. For every, I would say, data scientist, there has to be a subject matter expert to help the data scientist. So AI cannot go solo. The third thing is there is a strong prerequisite for AI, that is digitization, which I think is the level 0 of Ashtang AI of Silas' talk. Digitization is a key thing. So spend time and effort in digitizing your data and then start implementing AI. Doesn't matter whether your revenue is X or 100X or 1000X.
Yeah, that's the spot on, I would say, data. Digitization is the core of AI. I really like that. Yeah, over to you, Phani, now. Top 3 things that the industry should do to leverage AI.
Oh yeah, sure. So the way I look at it is like before you want to implement the AI and after you want to implement the AI. So before you want to implement the AI, the first thing you need to think is what problem you are trying to solve in your company, right? If you don't have the problem, there is no point in going for AI. I mean, most of the times you may think that it is fancy, but as Akansha said, it is going to be mandatory. So what problem you are trying to solve? And the second question is like, do you have the enough data? Okay. If you don't have the enough data, what is that you have to do to get the data? So these are the 3 things before you start implementing. And after you start implementing, by the time you get all these things, you will get some clarity. Okay. And if you have that confidence that you can solve that problem, probably you can take some risks. Okay. So you can revamp your whole system. Okay. But you have to be fearless. The same thing what you people are saying. Okay. And just take a little bit of risk, a calculated risk, and try to get that implemented. So the starting point is the data. If you have the data, you'll have a solution, and you need to know what the problem you want trying to solve. Okay, so that is what my take on this.
Thank you, Phani. That's really important. What's the problem that you're trying to solve? And from my side, top 3 I would be looking at is the leadership support, from the top, the corporate support. They need to actually embrace this technology. That's number 1. Second, you need to have a team in place, the right team in place. Third is, as Phani was mentioning, identify a problem where AI can actually deliver value or impact. Start small in one unit probably, and then once it's successful, you can scale it up. So these are the 3 from my side. So I think it has been a great experience, discussing about AI in the manufacturing sector with all the panelists, bringing out varied views, because each one of them are working in different areas within AI. I hope this session has been useful to all of you, and at least we were able to convey, what can the manufacturing industry do in terms of leveraging AI, what are the areas that the industry can immediately look into, to adopt AI, and what's the value that it delivers in various 3 areas that we have chosen. Thank you all. I thank all the panelists, for being here and actually taking out your time to be here. Thank you. Any questions from your side? 5 minutes. We can take 1 or 2 questions.
I'm Venu Verma. I'm representing European ecosystem here. But I don't see any big Indian company implementing anything in Industry 4.0. We are all followers. I hope to see more leaders, madam. Thank you so much.
Yeah, I think in the next 25 years, when India turns 100, you will definitely see that.
Sure, thank you.
Thank you.
So this question is to Nitin sir. Sir, I come from a chemical processing background. So basically, I wanted to understand, as the technology evolved to be implemented in a dynamic, in order, to implement in a dynamic actions. So for example, in chemical processing industry, you know that the time that reaction takes is like very small, the fraction of seconds, like it is up or down. So there are incidences like where accidents happen and etc. So is the technology evolved so that we can take in controllable actions within that shorter period of time? So is the data processing capacity is built now?
Two things. First of all, the real-time optimization which is right now in place has a window of 90 minutes to 1 hour based on the process residence time. It takes time for the process even to catch up to the optimization target. If you have a 1,000 meter cube tank, it will take time to drain that tank and fill that tank. That's a residence time or the time to process to activate. Now, how much of a dynamicity we are talking about depends on the process, right? Our controls are also made up for that only. When we design the control system, we consider the residence time of a particular reactant to the catalyst and then design the control accordingly. These days, from the deterministic side of modeling to a deterministic side of optimization, we are now moving to the more dynamic system. There are products which are right now challenging that particular paradigm. Right? There are companies which are experimenting with that. Right? And as you are a chemical engineer, you know that nobody will give you control unless until you do it at pilot plant study, pilot plant test, and then make that use case, make that particular case that my controller or my optimizer is good for the live plant after you do an open loop testing. Right? This time, the technology is on our side. Previously, the computational was not there, but now the computational is on our side. We have multiple clusters of processors which can calculate very finite floating point calculation, which is highly required for a very deep process optimization. Right? Previously, there were Intel processors which were highly targeted towards the integer calculation, like the server load, which will handle the requests of coming from an integer perspective. But from the engineering side, we are much more dependent on the floating point calculation. The 7th order decimal point, we are much more. So right now, GPUs and CPUs are capable of doing that. So we have the technology on site. Now, the systems which are now going to optimize dynamically has to respect that physical constraint, whether if I even ask the system to change, whether the system is able to change or not. Like, if you take example of a simple water heating, right? If a water will take 10 minutes to heat, it will take 10 minutes to heat. It cannot do very fast, even if you ask it to do it fast, unless until you have unlimited duty or heat source, right? So we need to respect these boundaries and then approach the dynamic point. So there are what we call as dynamic optimization suites. They are now able to do that as respected to the physical boundary. So yeah, we are approaching that. Why we are approaching that, I can give you an example. Right now, 5 years ago, when your Google Maps were there, it was giving you optimized route to your destination at one point. Right? You start saying that I want to go from here to Visakhapatnam, and then it will give you one particular route, and it will stick to that route. Nowadays, Google Map is dynamically optimized. It is able to give you new route based on the information coming dynamically. The weather, the traffic, the disruption in the road, closure, anything else, it will dynamically update and reroute your optimization. So same thing is possible and it's happening in industry, but it is taking its time because of the physical constraint. So I hope I have answered that.
Do we have any more questions from the audience? All right. Thank you, everyone. The discussion was indeed extremely thought-provoking and far-sighted. I'd like to request Natasha to present the speakers with tokens of appreciation now.